talk about genetic network and breeding pattern of cichlids lemon shark population in the society's island French Polynesia. In the beginning, I will talk about introduction. But before we start, I want to ask you one question. Why lemon sharks then have lemons? Is it because they're made by lemon, or is it because they eat lemons? Okay, the answer is they eat lemon. I know it's hard to believe, but don't worry, I'm just kidding. The real reason is because when you swim under the sunlight, their color skin was yellow-brown, and they can help them to camouflage as a sandy seafloor. So if they want to help hunting, they can get their food more easily. And you can see this picture, this female shark, you can see their skin color was yellow-brown, just like the lemons. And they live in less than 92 meters deep tropical water of the Indo-Pacific. You can find them in mangrove and coral reef. And they have violent mating behavior. You can see the male shark will bite female shark body in order to control the position of female bodies. It's a little bit painful. And this species viviparous, and this word is mean the baby shark develop inside the body of female rather than the egg. So you can see the baby shark come from their mother, not come from the egg. But unfortunately, those lemon sharks are vulnerable on the IUCN Red List. And this means the sharks are likely to be endangered because of human pressure like overfishing. So our aim is to investigate the genetic makeup and mating output with the small isolated shark populations. In our method, this study mainly conducted in Moria, but we also take some samples in Bora Bora and Tepiaroa. And we use underwater observation. The scar on the female shark can as a sign of mating behavior. So you can see this photo. Photo asks me this female shark, he was pregnant. And then he entered the resting time. Next, he was, in 2008, it was prepared to produce. So you can see the scar on her skin. And photo this, he was pregnant again in 2008. And the way how we get their DNA is we use spear gun. When we dive in, we will take this spear gun and we just swing across the lemon shark, and then we shoot the spear gun to the body and cut a little bit their body part, so we can get their body part to analyze their DNA. Right? You can see it here. And so we use microsatellite genotyping to analyze their DNA profiling, to analyze their gene sequence. So we get 85 lemon sharks to see if they have gene deficiency. Gene deficiency is mean they have chromosome disorder. Like this is normal chromosome. If he has the gene deficiency, they may have extra chromosome, or they may missing some chromosomes. So after we analyze their DNA, we will use Kerberos to see their mother offspring and father offspring. Kerberos is a computer program for analyzing the parents to their offspring. So we just put the DNA into this system, and it will help us to find parent, offspring, and sister. Sister means sister or brother relationship. And after we know their relationship, we will make a relationship construction between every shark. Like PO means parent, offspring, FS means four siblings, HS means half sibling, and U means unrelated. In this study, four siblings means the baby shark come from same father and same mother. And half sibling means the baby come from same mother but different father, or same father but different mother. So, the result. Microsatellite, we cannot find significant gene deficiency. And genetic structure, the mean coefficient of adult related is low. But all individuals are interconnected at least by one first-order genetic relationship. And that means you can see in this picture, circle is mean female shark and square is mean male shark. And every shark has linked by a black line. The black line is mean they have blood relationship, no matter it was strong or weak. And then it go to reproductive behavior of female. This figure is their reproductive behavior. Y-axis mean the female shark and x-axis mean ears. And this is the same figure for more easily to read. So you can see that 4 female sharks will return to the center story in the 2-ear circle, and 2 will return to the center story in competitive ear circle. In the other hand, the behavior of male, 10 of the 20 brothers sire more than 1 litter, and 5 male mating with multiple female in a single ear. So you can see in this figure too. From 2006 to 2009, every year has at least 1 male shark mating with more than 1 female shark. And we also find dispersal behavior. During each breeding period, most resident male will disappear from dead to weak, and non-resident will show up in the moria. And then the immature shark can disperse from birth location or change their nursery locations. So let's go to discussion and conclusion. In the reproductive behavior, female may follow an average 2-year reproductive cycle and did not immediately pregnant. So you can see in this figure, the female 13 he pregnant in 2007. Next time he pregnant in 2009. In 2008 it is not pregnant. So as male 1 and 2 and 3. No, not 3. And polyandry plays a major role. Polyandry means the female shark can mating with more than one male shark. So you can see in this picture, this female shark, and there are 2 male sharks swim after her. And this behavior you also can see in this figure. In 2006, female and he mate with 3 different male sharks. And the male almost never mate with female shark every year. So you can see in 2005 and 2006, male 10 he have mating behavior. For 2007 and to 2009, you cannot see male 10 on these figures. And next is genetic diversity. And this figure, the y-axis mean internal relatedness, we call IR. And x-axis mean maturity status. The IR is mean how diverse is the shark gene has. So you can see the juvenile is has higher IR and the mature is has lower IR. And that means the shark with lower IR has higher genetic diversity. And the shark with higher IR means the shark has lower genetic diversity. So you can see from juvenile to the mature, the IR value was decreased. So maybe you want to ask why. The reason is because the juvenile with higher genetic diversity have higher survival rate than the lower genetic diversity. And the juvenile with higher IR will migrating away from the pet they burn. So that's why the IR value will decrease. And so we found the juvenile with lower genetic diversity will be eliminated by natural selection. So that means if their parents have higher genetic diversity, their baby can have higher genetic diversity too, so as their offspring. And those sharks with lower genetic diversity will die or they will disappear because of maturity selections. So that's how they maintain their population and their genetic diversity. So in a conclusion, the isolated island system has encouraged the cycling lemon shark to develop different strategies to avoid inbreeding by dispersal and reproductive behavior. And that's how I report. And Although the time has not come, but I want to say Happy New Year.